All right, so let's continue talking about gases. Remember this little picture here. When we think about gases, what we think about is kind of particles or atoms flying around, colliding with each other, colliding with the walls. And so if you remember, so we'll take a look through this model and explain some properties of gases. And these properties are true throughout gases. Doesn't matter the gas. And then again, that's because the spacing here is very large. And so these gas molecules basically don't interact with one another. So again, what we're going to say is most gases behave approximately the same. Right, so let's take a look at some relationships between the properties of gases. So in this first picture that we have here, you can see we've kind of contained the gas in a closed container, so the gas cannot escape. And then we heat the gas, and when we heat the gas, the pressure increases, right? When we heat the gas, the pressure increases. And that makes sense. Remember, we said that gases, their temperature is kind of related to how fast they're going. And so when we increase the temperature, we basically just hit this wall faster and we hit this wall harder. So we increase the pressure. And so what we can say is that temperature is proportional to pressure. When temperature goes up, pressure goes up. So this little symbol here means proportional. It's kind of like an infinity sign with part of it missing. So what that means, as temperature increases, what happens to pressure? Well, pressure also increases. When temperature decreases, what happens to pressure? Well, pressure also decreases, right? The same thing that happens to one happens to the other. And you can logically think about it in terms of these gas molecules, either at high temperatures hitting harder or at low temperatures hitting less hard, and thus creating more or less pressure. So we can take a similar example to this one on the left here, but this time we can say that the container, the lid can be moved, the volume can be changed. So kind of what we're talking about here is a piston. So this is supposed to be a piston. So this piston is free to move up and down. And inside of here we have some kind of gas. And we're going to heat the gas. So when we're heating the gas, again, we're speeding up the speed at which the molecules are going. They're hitting the wall harder. But now we have a piston. This gas can push this piston up. So I'll make it like pink because it's like a hot gas. So again, we can see that temperature is also proportional to volume, right? As temperature increases, what happens to volume? Well, it increases. As temperature decreases, what happens to volume? Well, it decreases, right? So same kind of thing, volume, pressure, both have the same effect. All right, next up, we have this kind of syringe, and it's attached to a meter that's going to measure the pressure. So what we're comparing here is pressure and volume. Pressure and volume. So when we squeeze this syringe here, we're going to decrease volume, right? But if you think about what's happening to the molecules, now you're squishing the molecules in a smaller amount of area. So you're going to have more and more collisions with the wall with each other. And so those collisions with the wall will cause an increase in pressure. So as volume decreases, pressure increases, and vice versa. If volume increases, pressure decreases. And so what we say is that they're inversely proportional. So we put a 1 over one of them, right? So as the opposite happens here, as one grows, the other shrinks. And you can see There's some graphs here that show this effect. Go ahead, pause the video and take a look. And then finally, our last proportionality here is going to be volume and N. N we're going to call the number of moles. Right, so what's going to happen to volume when we increase the amount of moles? Well, think about a balloon. What happens when you blow more air into it? It expands, so it gets bigger. So increase in moles causes an increase in volume, so they are proportional to one another. And you can think all of these, in terms of a balloon, what would happen if you heat it, cool it. But you kind of want to have a good understanding of what happens and kind of why it happens.